If you are a student of HVACR looking to get into a career, as a matter of fact, a fantastic career, it's kept me engaged for 40 years. If you are a student looking to get into this career in a good, solid way, understand air. That's all there is to it. If you're an entry-level student, you get a handle on air coming out of the gates, boy, does that give you a competitive advantage. It gives you a great advantage in the workplace. If you're an existing technician trying to finesse your career, it gives you a great advantage. The more you know about air, the better off you're going to be. So, let's just take a quick look at the psychrometric chart. This is Fundamentals 101. We're not going to nail you on it. It's not time for us to nail you on it. That comes later. If you're in a program, if you're a program student, where this gets ugly and serious is in our course called 121, Air Properties and Measurement. Okay. This is an animated psychrometric chart. It's not really a chart that we would use to actually calculate air conditions and that kind of thing. We use this chart just sort of as an orientation. This is a chart we use in an orientation process just so that you can sort of get into where what means what, all right? So I'm just going to cursor over here. Here's the sensible heat ratio, and I'm not even going to go there. You can wait until you get into 121, and it's well explained there. So there's the sensible heat ratio. Then there's the wet bulb temperature. Just a quickie, wet bulb temperature is when air is totally saturated with water. And that temperature can happen at any point, actually. It doesn't happen so much below freezing because water freezes and turns to ice. Wet bulb temperature above 32 indicates at what point the air would be saturated with water. Dry bulb temperature is the temperature that everybody knows. You know, it's the temperature you listen to on the radio every 2 minutes. Dry bulb is the temperature you see on your thermometer, etc. It is the temperature of the air, dry bulb. Grains, pounds of water, nope, I'm not going there in this session. Volume, now we've already talked about volume. So this is a pretty easy lead-in. 15, 14.5, 14, 13.5, 13.0. What am I talking about? I'm talking about right there, 13.33 cubic feet per pound, standard air, okay? You can see it, it says cubic feet per pound of dry air. All right, so these are the specific volume indicators. Dew point, nope. We won't beat up dew point in this session too much. Just very quickly, dew point is when you cool a sample of air down to a certain temperature, dew point temperature. Anybody that's ever walked across the grass early in the morning and their shoes got all wet, well, guess what? The air cooled down overnight and got to the point of saturation, or what is called dew point. The water dropped out of the air, collected on the grass, and now it's collected on your feet, and your feet are wet. So that's a quickie on dew point. Relative humidity, yes, we talked about that. Standard air is 30% relative humidity, which would be right there, okay? 30% relative humidity. And those lines curve with this chart. Relative humidity means the amount of moisture that is in a sample of air compared to the amount of moisture that sample of air could hold. And relative humidity goes, for instance, if I have a sample of air, let's think about this. If I have a sample of air and it is, we'll just use 68 degrees, which is standard air, as you know now. And that's also 30% relative humidity, right? That's standard conditions. What happens if I cool that air down? If I cool that air down, the relative humidity is going to go up. So the relationship is like this. Temperature of air drops, relative humidity goes up. Okay, the colder the air goes, the higher the relative humidity goes, because cool air, what does it do? When you cool a vapor, if you know anything about your gas laws and that kind of stuff, when you cool the air down, what happens to the volume? Shrinks. It contracts, right? Okay, so I had this air, 13.33 cubic feet, 30% relative humidity. I cooled it down, let's say I cooled it down 20 degrees. Boom, air shrunk, okay, which I still have that water in that sample of air, but now that sample of air is smaller. So relative humidity goes up. Sort of like that. If you cool the air down enough, as relative humidity goes up, it's going to hit this line right over here, which is 100% saturation, and you're going to hit dew point. Go figure. Enthalpy. Ooh, ugly word, ugly word. Every technician I know goes, enthalpy? No, no, don't tell me that. I don't want to know. Give me a break, technicians. Come on, students. Are you in this business or what? Enthalpy is how much heat in a pound of air, okay? This psychrometric chart will allow you to calculate with only 2 values. That's all you need. There's all these values that we have here. 1, 2, 3, 4, 5, 6, 7, 8. If I know any 2 of those values, of those 8, I can calculate an exact condition, and from that exact condition, I can tell you every other condition. So 2 values, that leaves me 6 that are still open. I use 2 values. Generally speaking, it's dry bulb, wet bulb is the most common values that you plot on this chart. And from me plotting these 2 values, I can tell you all of these other ones because of the reference lines, etc. Enthalpy is how much heat is contained in 1 pound of air that's plotted somewhere inside this chart, whether the air is what temperature or whatever. You know, here's my dry bulb temperature lines right here, 32 through 120, right? So if I'm in that realm of dry bulb temperature, I can tell you everything else about it. So that's pretty cool. I love the psychrometric chart. You will either love it or hate it, one or the other. All right then. So there's a little indicator. Here's wet bulb temperature. Here's the way, of course, this is the antiquated way. Yeah, this is the old sling psychrometer. Maybe you've seen them, maybe you haven't. Maybe you will, maybe you won't. More than likely, you might see them in a museum somewhere anymore, but there's, I don't know, there's a number of technicians that probably still use them, and there's nothing wrong with that. Here's just an example of, you know, modern day technology. Here's a digital psychrometer. Much easier to use, by the way. All you gotta do is turn it on, you know, stick the probe in the airflow or wave it around in the air that you're trying to sample. And pretty soon it's going to tell you wet bulb, dry bulb. Nice, great tools. You got to have one of these in the biz, folks. I recommend the electronic model of some type. If you don't have one, you don't know what you're doing.